All right, good evening. Hope everyone is having a good night. We've got a couple questions posted in the live chat. Good to see that that feature is working again. First question, on the equation sheet, change in energy equals wavelength, equals wavelength times V equals HC over wavelength. What does that mean and when we would use it? I'm assuming that is in the hydrogen atom section. Today we talked about finding the energy of level in the hydrogen atom, and that equation is E sub n equals negative 2.18 times 10 to the negative 18th joules 1 over n squared. And that is the situation where you would put in the shell number or energy level for n. That allows you to figure out, for example, the energy of the fourth shell or the energy of the third shell. A little bit farther down from that, there should be another equation. Let me just see. I think I can see the equation sheet here. There should be right next to the equation you are asking about. There's an equation that looks like this, where it is, make sure I say this right here. The same value, 2.18 times 10 to the negative 18th joules, and then it's 1 over final shell squared minus 1 over initial shell squared. Sorry. If instead of like this first equation, where you can use it to figure out the energy of a specific energy level, this second equation is for an electron that's making a transition from the second shell to the fifth shell or sixth shell down to the second shell or so forth, where you have an initial and a final. Once you have that change in energy, the equation you are asking about, I think it's listed two ways. Change in energy equals, let's see. I'm just trying to read what this says. Let me go back to the equation sheet. Sorry. It's either written frequency times wavelength or HC over wavelength. You would only use this if you were asked to find then the wavelength for an electron that's making a transition, or the frequency that's making of an electron that's making a transition. We went over one like that today. We just kind of did it in two steps. It was on exam 3. We used this equation first to find the change in energy. I don't usually think of this as just a separate equation. Once you have this change in energy, other parts of the test, energy is H frequency, or energy is HC over wavelength. So once you find that change in energy, you just plug it in for E in either one of these equations, and that would allow you to get the either frequency or wavelength. Second question, do we need to know how to make ionization energy equations and or electron affinity equations? The answer to that is no. And for if someone's asking, well, what is an ionization energy equation anyway? Ionization energy is losing an electron. So if you are looking in your notes, you probably see equations that look something like this. Potassium losing an electron to turn into a cation, and then there's an extra electron that's being removed. This is an equation for ionization energy. We saw some questions like that on our original Chapter 7-8 test, but the questions you will see tomorrow based on the trends really deal only with just the trends. So given these 5 atoms, which of them would have the largest radius, which of them would be the most electronegative, which one would be have the least ionization energy. So you're just ranking, finding the elements and then finding the most or least for those different trends, atomic size, ionization energy, electronegativity, things like that. You will not have to write or recognize specific equations. And let's see, on the extra practice you handed out today, problem 6, how do we know when to fill up the poles or equator first in the ball and stick models? Okay, so if you are drawing structures and you're trying to then take that structure and turn it into a shape, you have to consider whether the structure you have has 5 domains or if it has 6 domains. So let's take an example with 5 domains. And let me just look at the key here for a second. One with 5 domains. I don't think I have one on there like that. If you had, like, for example, phosphorus pentachloride, PCl5. Phosphorus, when you draw the structure, it would be, I'm going to start over. Just going to go with generic structures. I think it'll be easier to understand. If you have 5 domains versus 6 domains, the difference is if you have 5 domains, you always put extra electron pairs in the equatorial positions. So here's the base shape for 5 domains. That electron domain geometry is trigonal bipyramidal. And if you have 5 domains and one of those spots is going to be an electron pair, then you put them always on the equatorial. So for 5 domains, electrons on equatorial. That's how we get, if this one was electrons, that's how you get seesaw or T-shaped, for example. If there are 6 domains, though, then you want to always put the electron pairs, if there are some, in the axial positions. So your base shape for 6 domains is octahedral. Sorry, that's our dishwasher beeping. Octahedral. And if you have then electron pairs that are going to take some of those spots up, we end up putting those on the axial positions. So for example, that's how we get trigonal pyramidal, square pyramidal. Or if there's 2 pairs of electrons, you'd put them on both the upper and bottom axial positions, and that's how we get square planar. So rule of thumb, if you have 5 domains, extra electron pairs on the center go on equatorial, and for 6 domains, electron pairs that are extra are on axial positions. All right, other questions that are out there. Let me just check email to see if any others have come there. Doesn't look like it. Any other questions for anyone else that's out there? Glad the chat or live chat feature is working. Any other questions? All right, well, happy studying. Email me if you think of anything else or stop in tomorrow. I'll be here in the morning. Hope you guys have a good night.